Hello and welcome to another video where we will learn about box plots and how to use box plots for comparing data. All the important information about box plots are on this picture here. So median is in the middle, lower quartile, so-called Q1, is 1/4 through the data, upper quartile is 3/4 through the data. The left whisker is usually the lowest or the smallest data value that is not an outlier, and if we don't know what this is, we can instead plot here the boundary for outliers. The left one is usually 1.5 times interquartile range to the left of Q1, and in the same way the right whisker is either the largest value of the data, and if that is not an outlier, and if we don't have it, then we can instead do the boundary, which is usually 1.5 times interquartile range, starting from Q3. So Q3 plus 1.5 times IQR. Obviously, outliers to the left or to the right are any data values which are smaller than this range here. When we are asked to compare the data, there are two rules. If there are no outliers, then we usually use the mean and standard deviation for comparing the data. If there are any outliers, then we should use the median and interquartile range. So let's have a look at a couple of examples. In this first example, we are asked to find the range and interquartile range and then compare the data. So as we can see, there are two outliers. So range is always the largest value, which is here 92. Take away the smallest value, which is here 20, so it's 72. Interquartile range is upper quartile, 58. Take away the lower quartile, which is 26. And so in this case, it's 32 minutes. And because there are outliers, we have to use the median and interquartile range if we were asked to compare this data with another data. So in this example here, you can pause the video, try to answer it. You need to sketch the box plot, and then we will go together through the answers. So let's go through the answers. We are asked to complete the box plot at the top of this slide. So the interquartile range, as you can see, must be Q3, which is 26.6, take away Q1, which is 19.4, because one small square is 0.1. And now we can calculate the upper boundary, which is again 1.5 times interquartile range plus the Q3, which will give us 37.4. And because 32, which is the highest air temperature, is smaller than this, it's not an outlier. And in this case, we can put here the largest data value, which is 32.5 for the whisker on the left side. The lower boundary, again, doing Q1, take away 1.5 times interquartile range is 8.6. And so we can either plot here 8.6, which is the boundary, or because 9.1 is more than 8.6, we could also do this whisker at 9.1. You can use both answers, 8.6 or 9.1. And obviously these two numbers, 7.6 and 8.1, they are smaller than the lower boundary, and therefore we have to plot them here as two outliers. And finally, the third example, again, you can pause the video, try to answer the questions, this question, and then we will look through the answers together. Here is the answer, the box plot, and let's just go through the steps. So they gave us the median 1.85, 25%, which is Q1, is at 1.81 because they said 25% of heights are below. So Q1 must be 1.81. Again, one small square is 0.1. Upper quartile, Q3, is the lower quartile plus the range. The range was 0.11, so the upper quartile must be 1.92. The left whisker is the shortest player, 1.72. We were given this number. And the right whisker, the tallest player, will be 1.72 plus the range, which was 0.28. So it's 2.0, which is here. And that's the end of this video. Thank you for watching.